Today we're going to find the domain, x-intercepts, and asymptotes of logarithmic functions. We did not finish these notes in class today, so I hope this will help you as you prepare. So let's begin with example number 1, y equals the natural log of x minus 4. I've put a picture of the graph of the parent function of the natural log on here to remind you of a couple of things. First, there is a vertical asymptote on the parent function at x equals 0, and there's an x-intercept on the parent function of 1, 0. And we're going to refer to this graph as we find the domain, the x-intercept, and the vertical asymptote. So what I would like for you to think about first is the transformation that's here. You know this is not the parent function because we're subtracting 4 from x. And so our transformation would be to shift everything in our function right 4 places. So the vertical asymptote is going to go to positive 4. The x-intercept will go to positive 5. And then we can also see that our domain moves from 0 to positive infinity to 4 to positive infinity. But now that you've seen the graphical, I want to talk about how do we find all of these things algebraically so you don't always have to draw or sketch a graph. So if the domain of the parent function is from 0 to positive infinity, that means that our domain is always x is greater than 0. So to find the domain of a non-parent function when we have transformations, we would take the value that causes the horizontal transformation, or the value that we're taking the log of, and set that greater than 0. Solve for x. And now we know that our domain is greater than 4, or from 4 to positive infinity. To find the vertical asymptote, well, because the domain is of the parent function is greater than 0, and 0 has the parentheses, we know that the vertical asymptote of our parent function is x equals 0. So we can take x minus 4 and set that equal to 0, and we know that the equation for our vertical asymptote in this case is equal to 4. And finally, the x-intercept. Our x-intercept we know is where y equals 0. So set our function equal to 0. The base of a natural log is e, so I will rewrite this in exponential form. E to the 0 power equals x minus 4. E to the 0 power is 1, and that is equal to x minus 4, and when we add 4, x is equal to 5. Now, if you want to be a little bit math savvy, and rather than setting the function equal to 0, you can think about the parent function. The x-intercept of the parent function, you know, is always equal to 1. So you could set x minus 4 directly equal to 1, which is what happens when you raise e to the 0 power. You would add 4 to both sides, and now your x-intercept is 5. So let's practice the next example, finding these pieces of information algebraically rather than graphically. So I have the graph here for you to look at just to serve as a reminder. We know that our domain of the parent function is 0 to positive infinity, or greater than 0. So I will set 4 minus x greater than 0. I will add x to both sides, and x is less than 4. If you want to rewrite that from left to right, that's fine. So our domain, remember this is the parent, it is not the natural log of 4 minus x. So our domain is from negative infinity to 4. Remember that the vertical asymptote will always line up with the endpoint of the domain. So our vertical asymptote should be x is equal to 4. Let's see. If we set 4 minus x equal to 0, 0 is the value of the vertical asymptote of the parent function, we do get that the vertical asymptote is 4, the equation. And finally, our x-intercept, we know that the x-intercept of the parent function is always equal to 1. So if we set 4 minus x equal to 1, I will subtract 4 from both sides, and that gives me 1 minus 4 is negative 3. And divide both sides by a negative, the x-intercept is at 3, 0. Let's take a look at example 3. Again, I have shown the parent function of a log graph here just to give you a visual to help you remember about domain. All right, so when we're calculating the domain, remember the domain of the parent is x is greater than 0. So we take x squared minus 9 and set that greater than 0. We're finding our domain. Well, this is a quadratic. This is not a linear function. Remember, if this is a quadratic, then we have to use the number line test to find where the product is greater than 0. So x squared minus 9, as you know, will factor into x plus 3 times x minus 3. So we're finding where this product is greater than 0 or positive. On the number line, we need to put our zeros. X plus 3 has a 0 of negative 3. X minus 3 has a 0 of positive 3. So let's test some numbers along these 3 intervals so we know where we are positive. From negative infinity to negative 3, you pick an x-coordinate of negative 10. So f of negative 10, if we plug negative 10 in, negative 10 squared is 100. 100 minus 9 is a positive. To select the second interval, I'm going to choose 0. 0 is between negative 3 and 3. 0 squared minus 9 gives us a negative. And then from 3 to positive infinity, I will test f of positive 10. 10 squared minus 9, 100 minus 9 is a positive. So remember, we're looking for where our intervals are greater than 0 or positive. So the interval from negative infinity to negative 3 with an open circle, and from 3 to positive infinity would represent our positive domain. So we can say the domain of this function is from negative infinity to negative 3, parentheses, because there's no equal. Remember, if we equal 3, 3 squared is 9, 9 minus 9 is 0. We cannot take the log of 0 because there's a vertical asymptote there at the parent function. So this is the domain of our function. Remember that the vertical asymptote of the parent function is at x equals 0. So we would take x squared minus 9 and set that equal to 0. Remember, inside the parentheses is where the horizontal transformations take place. A horizontal transformation would affect the y-intercept. To solve this function, we can add 9 to both sides and then take the square root, and we get that our vertical asymptotes, we have 2, positive and negative 3. And you would see that would make sense because of our domain is from negative infinity to negative 3, and then 3 to positive infinity. Let's finish up by calculating our x-intercepts. Remember, the x-intercept of the parent function is equal to 1. Take where the horizontal transformation takes place inside parentheses, so we set that value equal to 1. To solve for x squared, I'll add 9 to both sides, and that gives me 10. To solve for x, I'll take the square root of both sides. So I have two x-intercepts at plus or minus the square root of 10. So those x-intercepts, positive or negative, root 10, 0. Let's look at our final example, number 4. Y equals log base 3 absolute value of x. So you may notice there is no horizontal shifting here, but we are taking the absolute value of x. So this is not the parent function. I have graphed the parent function just to help you remember to look at this to help you with the domain and with the other parts that we're looking for. So let's begin looking for the domain. The domain, you know, is where the function is greater than 0, so we'll set the absolute value of x greater than 0. Remember, when you are solving an absolute value inequality, you are finding where x is greater than 0 or where x is less than 0. Remember, absolute value is our distance away from 0. So if you look at this on a number line, just as a quick reminder, values that are greater than 0 units away would be to the right and to the left. So greater than 0 and less than 0. If we put this on a number line and graph, we'd have an open circle at 0, shade to the right for x is greater than 0, shade to the left for where x is less than 0. So our domain is from negative infinity to 0, union 0 to positive infinity. Now, if this writing the equations and looking at the number line confuses you, then think through what values would cause us to take the log of 0 or a negative number. Well, we definitely would never be taking the log of a negative for this function because the absolute value of a negative gives us a positive. So the only place we could not take the log is at 0. Let's find the vertical asymptotes. Remember, for the vertical asymptotes, we set the horizontal portion of the function equal to 0. 0 is where the parent function's vertical asymptote is located. And to solve, it's just x equals 0. And that also corresponds to the domain. Lastly, our x-intercept of the parent function, you know, is equal to 1. So we would set absolute value of x equal to 1. How do we solve with absolute value equal to 1? Well, if you look again, tell me which values on this number line have an absolute value of 1. Remember, absolute value is distance from 0. I know that 1 is 1 unit from 0, and I know that negative 1 is 1 unit from 0. Or I know that the absolute value of 1 is 1. I know the absolute value of negative 1 is 1. So we would have two x-intercepts, one at negative 1 and another at positive 1.